very strangely shaped, and it comes from another star. And that's what has everybody looking at it with every telescope they can find.
When the James Webb Space Telescope turned its powerful eye toward the distant object known as Oumuamua, scientists and enthusiasts around the world held their breath. For years, this strange interstellar visitor had eluded full understanding, having zipped through the solar system in 2017 with a shape and behavior unlike any known comet or asteroid. Many theories flourished, from icy body to alien artifact, yet the mystery endured. But with the Webb telescope's cutting-edge capabilities, humanity has finally gotten its first real image of Oumuamua, an image not blurred by limitations, not reconstructed through guesswork, but one that stares directly into the heart of the unknown. And what the telescope revealed is nothing short of extraordinary. Before we start, smash the like and subscribe buttons for more updates. The image shows a slender, elongated object gliding through the emptiness of space. Its surface, cold and muted, reflects sunlight in a way that appears eerily unnatural. Unlike typical asteroids, which often resemble tumbling rocks, this object maintains a surprisingly consistent orientation, hinting at some internal stability or even design. From its distinct reddish hue to the unusual symmetry along its long axis, the Webb telescope's view cuts through years of speculation. The contours are smooth, almost sculpted. The reflections vary ever so slightly as the body rotates, suggesting surface material that shifts light in ways previously undocumented in natural objects. The precision of the image allows scientists to observe features never before visible. There are no signs of a tail, no volatile substances gassing off from the surface, something expected if it were a typical comet. Instead, the structure appears monolithic, with segments of differing reflectivity, hinting at materials of various compositions. One side glints faintly with a metallic sheen, while the other seems darker, more porous, possibly carbon-rich. Most intriguing of all, however, is the subtle banding across its middle. Linear patterns that suggest the presence of structure, not simply the randomness of rock. These lines are neither cracks nor shadows, but ridges or grooves that wrap around the object like rings on a cylinder. The Webb telescope, designed to peer farther into the universe and deeper into cosmic origins than any instrument before it, wasn't initially tasked with chasing interstellar interlopers. Yet its infrared sensitivity, powerful enough to detect the dimmest heat signatures and minute variations in reflected starlight, made it the perfect candidate for studying Oumuamua in detail. As it tracked the object across the black canvas of space, the telescope delivered frames rich with data. Every pixel became a window into this object's secrets, each frame sharper than the last, peeling away the assumptions that had clung to it for years. One of the most compelling observations concerns the object's rotation. Earlier analyses from ground-based telescopes and older space-based observations suggested a chaotic tumble. But Webb's high-resolution imaging reveals a different story. The rotation, it turns out, is not chaotic, but precisely rhythmic, almost engineered. It rotates along a stable axis with slight precessions that follow a regular periodic pattern. This motion is rare among natural objects, especially ones that have supposedly traveled across interstellar distances without gravitational anchoring. It implies a balance in mass distribution and shape that's hard to attribute to random formation. Surface temperature readings, derived from the Webb's infrared sensors, show another anomaly. The temperature distribution is not what would be expected for a passive object merely absorbing and radiating solar energy. One hemisphere appears to maintain a consistent warmth that doesn't fluctuate in the way it should as the object spins. This suggests internal heating or insulation, properties rarely associated with asteroids and comets, particularly ones that originate outside our solar system. There's a controlled gradient to the heat signature, as if the object is managing its thermal environment. Chemical analysis based on spectrographic data reveals materials that defy easy classification. Trace elements point to a combination of silicates, organic compounds, and metals, some of which do not match known patterns in solar system objects. The reflective surface contains a thin layer of material resembling ultra-thin metal films, akin to vapor-deposited coatings used in advanced manufacturing on Earth. While such features could theoretically form through cosmic processes, the purity and distribution of the coating are highly unusual. Some areas even appear to refract light in a manner more common to engineered lenses than natural surfaces. The image and accompanying data provoke immediate, intense questions. If Oumuamua is natural, it is an example of a formation process never before witnessed. perhaps a fragment of a shattered planetary crust, or the crystalline spine of a long-dead celestial body. If artificial, the implications are staggering. The Webb image does not scream spaceship, but it does not resemble a lifeless shard of rock either. It occupies a strange in-between space, too regular to be random, too alien to be familiar. The motion of the object across the solar system, observed in tandem with the new imagery, also adds fuel to speculation. Oumuamua did not follow the trajectory expected of passive objects under solar gravity alone. There was a small, unexplained acceleration noted during its departure from the inner solar system. Previous models speculated this could be due to outgassing or internal jets, but no such activity was visible even under close inspection by Webb. The new images confirm the absence of vents, craters, or fractures that could suggest the release of gas. The object appears perfectly intact. Furthermore, the lack of a detectable debris trail is noteworthy. Even interstellar objects tend to accumulate microscopic impacts and trails of dust from their journeys. Oumuamua appears pristine, as though it has somehow repelled space detritus or cleaned itself. Its edges are not worn or pitted, but smooth, unblemished. This level of preservation is difficult to reconcile with billions of years of interstellar travel. It may indicate that the object is much younger than previously thought, or that it has some means of withstanding the erosive effects of the interstellar medium. There's also the issue of trajectory. The object entered our solar system from an unusual angle, not aligned with the typical galactic plane. This suggests a launch or ejection from a different kind of stellar neighborhood. Perhaps a rogue planetary system, or a star with dynamics very different from our Sun. The image's details allow for a re-evaluation of the object's origin. Mapping the reflected stellar spectra captured on its surface, astronomers can now match those light fingerprints with star systems far beyond our own. Early analysis points to a red dwarf system located nearly 300 light-years away, a region known for its abundance of planets, but also a hotspot for cosmic turbulence. The newfound clarity offered by the James Webb Telescope pushes the boundaries of what can be interpreted from a single object. In some frames, subtle pulses of infrared light seem to emanate from within. They are too faint to be considered signals, too regular to be dismissed as thermal fluctuations. A pattern emerges, an oscillation in the near-infrared band, recurring every 27 hours. Whether this is a natural thermal resonance, a structural response to solar radiation, or something else entirely, remains unknown. It's the kind of mystery that blurs the line between the possible and the speculative. Scientists examining the data find themselves caught between the imperative to remain grounded in known physics and the undeniable peculiarities laid bare by Webb's imagery. The fine surface striations, the lack of thermal variation, the consistent orientation. All of these traits could potentially be explained by exotic but natural processes. Yet none of those explanations feel sufficient on their own. Together, they build a case for uniqueness that transcends typical cosmic wanderers. The resolution of the image captures the surrounding environment as well. There's no evidence of any accompanying fragments, no orbiting debris or secondary objects. Oumuamua travels alone. Its isolation in space, combined with its peculiar design, enhances the sense of intentionality. If it were a fragment from a larger structure, as some suggest, it must have broken away cleanly and intact. If it were a probe of some kind, it shows no signs of activity beyond its mere presence. But presence, in this case, is everything. Every mission to understand the broader universe seeks something more than just matter and motion. It searches for connection, for patterns that hint at life, intelligence, or at the very least, origin. Oumuamua, viewed now with this unprecedented clarity, becomes a mirror not just of light, but of curiosity. It represents the possibility that we are not merely looking outward, but being noticed in return. That feeling of being observers and maybe, just maybe, the observed carries an emotional and philosophical weight far beyond scientific data. The implications of the Webb image extend into astrophysics, material science, planetary formation theories, and the philosophy of space exploration. The object forces reconsideration of what interstellar debris might be. It raises the question of how many other such objects have passed through unnoticed, their secrets locked behind the limits of our instruments. With Webb's success in capturing this image, a new priority emerges: scanning the cosmos not just for stars and galaxies, but for the silent travelers between them. As researchers pore over the data, new models are being constructed. Some propose that Oumuamua is part of a broader category of cosmic relics, interstellar archives perhaps that drift across the galaxy for eons, transmitting nothing but their form, awaiting discovery. Others consider that it may have once been active, perhaps long ago, its power source now dormant. Still more cautious voices suggest that the object, while bizarre, could simply be the first of many such anomalies, each reshaping our understanding incrementally. But few can deny the visceral reaction that the Webb image evokes. There is something about seeing this object, not as a blur, not as an artist's impression, but as it truly appears, that stirs the imagination. It feels as though the universe has opened one of its hidden doors, if only slightly, to offer a glimpse of what lies beyond. The revelation doesn't close the chapter on Oumuamua. Rather, it opens countless new ones. Its image, crystalline and provocative, now joins the pantheon of human discoveries that demand more than answers. It demands wonder. And wonder in this case is not passive. It drives the next questions, the next observations, the next generation of telescopes. The James Webb Space Telescope has not only provided the clearest view of Oumuamua ever achieved, it has reignited a pursuit, a chase after interstellar truth that will not slow down. Somewhere out there, more Oumuamuas may be drifting silently through the dark, each carrying its own story. And now, we are watching. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Oumuamua's true nature? We want to hear from you. Thank you for watching and see you next time.